Now let's see this question. Finally, this beautiful question has come. This question will take some time because we will do the complete analysis of this question. So you take your copy pen. Okay. If you want to understand this question in the best way, then don't watch it like a movie. I'm doing it. I'm solving it. I will do the complete analysis of this question. You can also solve with me. So let's solve this question. What this question is saying, this is GATE 2006 question. The 2 power n vertices of a graph. There is a graph which has 2 power n vertices of a graph corresponds to all subsets of a set of size n. N is greater than or equal to 6. So there is a set. So there is a set S whose size is n. There are n elements. Now we are creating a graph whose vertices are basically subsets, whose vertex is basically power set of S. Okay, means there will be 2 power n subsets, right? There will be 2 power n subsets. So these subsets are the vertices. These subsets, these 2 power n subsets, these are the vertices of G. These are the vertices of G. Now what this question is saying, 2 vertices are adjacent if and only if the corresponding set intersect in exactly 2 elements. So what this question is saying, this is saying that if you have this set A1 and if you have this set A2, they will be adjacent if and only if A1 intersection A2, this cardinality should be equal to 2. Okay, means they intersect in exactly 2 elements. They intersect in exactly 2 elements. Is this clear? So very simple. This is if and only if they intersect in exactly 2 elements. Like A1 intersection A2, cardinality is 2. Okay. Now the question is asking the number of vertices of degree 0. How many vertices have degree 0? First of all, did you understand this question? Okay, the question is simple and beautiful. First, let's understand this question. Consider this like do not worry about this n greater than or equal to 6. Do not worry about it. Like you can take if you want, but anyway, let me take a simple example. So let's assume that as it can have like, for example, okay, 6 elements. At least 6 elements must be there. The question is saying. So let's take 6 elements. No problem. 1, 2, 3, 4, 5, 6. So let's assume this is your set. Now we are creating a graph in which the vertex is basically the power set of S. Okay, and we are putting edges. What the question is saying, you know that there are 2 power 6, that is 64 subsets. These subsets, all these subsets, these are the vertices of G. We make them vertices of G. Okay, and what this question is saying, and the question is saying that if you have 2 vertices, okay, like if you have 2 vertices, for example, I can say S1 comma S2, these are, let's assume, subset of S. Okay, so now the question is saying that S1, between S1 and S2 there is edge. There is edge if and only if there is edge, if and only if S1 intersection S2, they should have exactly 2 common elements. Remember, it means they must have exactly 2 common elements. Is this clear? So it simply means that S1 comma S2 have exactly 2 common elements. S2 have exactly 2 common elements. Okay, so what will happen actually in this? For example, you tell me this will be a vertex. Like let's look at the graph G. Let's look at graph G. In this graph G, like this will be a vertex. For example, this 5 will be a vertex, or I can say maybe like this 5 will be a vertex. This also will be a vertex. This also will be a vertex. This also will be a vertex, 3, 4. Like this 1, 2, 3. This also will be a vertex. This also will be a vertex. So you tell me, okay, for example, 1, 2, 3, 4. This also will be a vertex. So these are the vertices. Okay. So this is a vertex, 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 vertex. Okay, so you tell me, like there will be many more, of course, there will be many more. Total 64 vertices are there. There will be many more vertices. So you tell me which of them are adjacent. Can you tell me? Can you tell me which of them are adjacent? So you can easily see that this can never be adjacent to anyone. Do you agree? Do you agree that this can never be adjacent to anyone? Because if two people are adjacent, what it means? It means they have exactly two common elements. Exactly two common elements. Okay, exactly two common elements. So this cannot be adjacent. So this will be isolated. Can I say this will be isolated? Because this cannot have two common elements with anyone. This vertex, look at this vertex. This vertex cannot have any, this vertex cannot have, this set cannot have exactly two elements common with any set. Similarly, this cannot have two common elements with anyone. This set cannot have two common elements with anyone. So this is also isolated. You can notice these will be adjacent. These will be adjacent. The reason is very simple. They have exactly two common elements. Okay. These will be adjacent. They have exactly two common elements. What about 1, 2, 3 and 1, 2, 3, 4? What about these? 1, 2, 3 and 1, 2, 3, 4. These will be not adjacent. Yes or no? Like this and this. Look at these two. They are not adjacent. Correct? Because they have three common elements. 1, 2, 3, 1, 2, 3, 4. They have three common elements. So they are not adjacent. Correct? You can see 1, 2, 3, 4. These are not adjacent. Okay. What else? You can see this 3, 4 is adjacent to this. This 1, 2 is adjacent to this. Okay. Similarly, this 2, 3 is adjacent to this. So like this. I hope you understood. Now these are not adjacent. Look at this one. For example, I can say, look at this and this. These are not adjacent because they have one common element. Is this understood? Clear? Please tell me. The question is understood. Who are adjacent, who are not adjacent? Which two vertices are adjacent, which two vertices are not adjacent? Okay. So now let's solve. So how many vertices do not have any one like isolated vertices? The question is asking number of 0-degree vertices. So the question is asking number of isolated vertices. Okay. So you have total n 2 power n vertices. How many isolated vertices will be there? So you can notice that if you have this set, remember your set is like this, total n elements you have. This is your set S, in which you have n elements, where n is already given. In the question it is given. But your graph is like this. Okay. So the power set is the set of vertices and there are edges, we already know. Now in this graph, what are the isolated vertices? Which vertices are isolated? So you can notice that this vertex is isolated. This vertex is isolated, right? So I can say 0 size subset. This is your 0 size subset. So this is isolated. This is not connected. This is not adjacent to anyone. Similarly, one size subsets are also isolated, right? One size subsets. They also do not have two elements common with anyone. Okay, like for example, look at this set, and so on. And so on. What about the remaining? Can you guarantee they will not be isolated? Can you guarantee? Can you guarantee that remaining will not be isolated? What about the remaining? Like you have at least 6, n is greater than equal to 6. In your graph, you have 2 power n vertices. In this graph, total you have 2 power n vertices. Can you guarantee that the remaining vertices are not isolated? Why? See, if you take any vertex, for example, if it has size 2, let's assume it has size 2, then it will be adjacent to this. Array, it will be adjacent to this. If you have 3 size, for example, if you have 2, 1, 3, then this will be adjacent to this. Like whatever set you take, if you have 1 2 3 4, whatever set you take, this will be adjacent to 1 comma 2. Like if you take any set 1 2 3 4 and so on k, where k is greater than equal to 2, where k is greater than or equal to 2, if you take any set, if you take any set k, then this will be adjacent to 1 comma 2. Are you getting my point? So whatever set you take, that will be adjacent. There will be edge, there will be edge, edge, edge. So you can guarantee that remaining are not isolated. Yes or no? So only these are isolated, no other is isolated. No one else is isolated. No other vertex isolated. No other vertex will be isolated. Okay. So finally, your answer will be how many isolated vertices? That will be 0 size subset will be 1 plus. Okay. So that is 1. And how many one size subset? How many one size subset? That will be n, nc1. So that will be nc1. That is your answer is n plus 1. So your answer is going to be n plus 1. N plus 1. Okay. So this will be your answer. This is clear, right? Yes or no? So a nice doubt Dipan is asking. Dipan is asking, will they have self loop? Like for example, this 1 to 1 2, will they have self loop? Tell me. So this is the student doubt. Student doubt is that, will we have self loop? For example, if you have this vertex, like this is your vertex, will this vertex have self loop? Yes, of course it will have self loop, right? The question is simply saying that there are 2 power n vertices and 2 vertices are adjacent. If this happens, yes, there will be self loop. Okay. So yes, there will be self loop. This is student doubt. So yes, there will be self loop. Okay. So all the 2 sides subset. Okay. Like if you have 2,6, then this will have self loop. Okay. So all of them will have self loop. Okay. So this question number 1 is over. Is this clear? So very beautiful question. The answer is n plus 1. These many isolated vertices we have. Now let's move on. Now let's see this. Another, actually the same question, but it's another part. It's second part. For the same question, the second part. The question is same. There are 2 power n vertices, subsets of size, which are these vertices are subset of size, subset of a set of size n. N is greater than equal to 6. 2 vertices are adjacent if they intersect in exactly 2 elements. Same question, but maximum degree is asking. The question is same, but the question is asking for maximum degree. What is the maximum degree? And this is really beautiful question. In the GATE exam, how can you solve it? Before we see the complete analysis, during the GATE exam, how can you solve it? See what I am saying. I am saying that during the GATE exam, how can you solve it? Like the question is saying there is a set S which has n elements. Okay, the question is saying that n is greater than equal to 6. And the question is saying we are creating a graph in which vertices are subsets of S. Okay. Now in the GATE exam, how can you solve it? During the GATE exam, like this is what I'm saying. During GATE exam, during those 3 hours, how can you solve? So during those 3 hours, you can solve like this. What you can do? You can just take S cardinality equal to 6. You can take S equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can take like this. Okay. Because it should work. The question is saying n is greater than equal to 6. So it should work for n equal to 6. So you can take S equal to this. Okay. This you can take. Now what you can do? Now you can easily see. A simple question I'm asking you, tell me, all the 2 size subset, will they have the same degree? All the 2 size subset. So you can notice now, what are the vertices? Now you can see these are vertices of G. What are the vertices of G? These are the subsets of S, right? Subsets of S. So you can divide them like this. Here you have 0 size subset. It will have degree 0, right? It will have degree 0. There is nothing. So here you have nothing to worry about. So here I am writing subset size. Okay, subset size. And then I will calculate degree. of that vertex. Okay, so subset size, basically, like if vertex like if your subset size is 5, then the degree will be basically subset size is 0. Here you have subset size is 0. It simply means that yours this is your vertex 5. It simply means you have vertex 5. So if you have vertex 5, then degree is 0. Correct? There is nothing here. If your subset size is 1, like vertices like this, these are the vertices. What are the vertices? Like vertex 1, vertex 2, and so on. Okay, vertex 6. These are the vertices. So they also have degree 0. Nothing to worry about. Okay, now you tell me, if you have size 2 vertex, like consider any vertex, they are symmetric, right? Yes or no? Do you agree that if you take any two size subset, whether you take 1,2 or whether you take 2,5, it does not matter, right? Correct? This degree will be same as this degree. Okay, because there is complete symmetry here. So you can notice that whether you find degree of this, whether you find degree of this, they will always be same. There is no changes. Okay, so now what you can do, now you tell me a particular vertex you take, like for example a vertex, let me take this vertex 1,5. Consider this vertex. What will be degree of this vertex? It will be adjacent to every superset. Do you agree? It will be adjacent to every superset. Yes or no? This will be adjacent to every superset. This 1,5, this will be adjacent to every superset. Whatever superset you create, this will be adjacent to that. Okay, this 1,5, whatever superset you create, it will be adjacent to that. How many supersets are there? For this 1,5, how many supersets are there? The remaining elements have two choices, yes or no? These are the elements 1 to 6. So how many supersets are there? These remaining elements, look at these remaining elements. Look at these remaining elements. They have two choices. Whether you take them or you don't take them, they have two choices, two choices. So the remaining elements have two choices. 4 elements are there, then they have two choices. So there will be 2 power 4. The degree will be 2 power 4. Okay, so the degree, remember self loop is counted here. Do you agree? Here self loop counted. Okay, because self loop will be there in the question. The way this question is created, self loop will be there. Self loop included. We have included the self loop. Okay, because we are considering all the subset. So this will be the degree. Okay, what about three size vertex? Like if you have 3 size vertex, for example 1, 3, 4, what will be that? This will be adjacent to whom? Like look at this 1, 3, 5. Let's check it out. This is your vertex 1, 3, 5. 1, 3, 4. This is your vertex. Look at this vertex and you tell me, focus on this vertex. You tell me, it will be adjacent to whom? It will be adjacent to, if you are taking 1,3, then you cannot take 4. Agree or not? You cannot take 4. This 4 you cannot take. Remaining you can take anything. Remaining you can take anything. Yes or no? Correct or not? See, you are taking 1,3, you are taking 1, you are taking 3. You cannot take 4. If you take 4, then they will not be adjacent. They will not have exactly 2 common elements. If you take 4, then they will have 3 common elements. But we want exactly 2 common elements. So here you can take anything from the remaining elements. From the remaining elements you can take anything, any superset. So tell me, this will be like this. How many people like this? How many people like this? This type of how many people are there? This type of how many people are there? Tell me. This type of how many people are there? So this type of how many people you have for the remaining elements. How many remaining elements? There are n minus 3 remaining elements, correct? Because, so actually like in the same question, if you have n, instead of 6, if you have n, if you generalize, okay, we will generalize after some time, but remaining 3 elements, anything you can take. So 2 power 3, correct? 2 power 3, anything from remaining 3 elements. So remaining 3 elements, you can take any superset. So this will be 2 power 3. Yes or no? But we can also do this. We can also take 1 comma 4. We take 1, we take 4. We don't take 3 and then we do. This is also possible. So this type of how many people are there? This type of 2 power 3 people are there. But what we can do? We can do this. We can take 3, we can take 4. We don't take 1. Like we take 3, we take 4. We don't take 1. Then remaining how many people like this? This type of how many people? Again 2 power 3 people. Okay, is this clear? What is happening here? So again, you can easily see that what is the degree of this vertex then? What is the degree of this vertex? That will be 2 power 3 plus 2 power 3 plus 2 power 3. That is going to be 3 into 2 power 3. 3 into 2 power 3. Understood? Please tell me, is it understood? See, you can very quickly do this. If you don't want to do like this, you can very quickly do this. Just for understanding, I am telling you like this, but you can easily see like this. This is your vertex. Your vertex is 1, 3, 4. Now what you can do? This vertex, see, this will be adjacent to whom? Just think about it. This will be adjacent to whom? Okay, this will be adjacent to that person which have 2 elements from here. Okay, like exactly 2 elements from here should come. 2 elements should come. Exactly 2 elements. Okay, exactly 2 of, consider, let's call it A1. Exactly 2 of A1 should come here. Exactly 2 elements of A1 should come here, right? The third element should not come. Like exactly 2 elements should come, and the remaining, here you can have any, here you can have anything. Okay, from, there are remaining 3 elements. Who are those remaining 3 elements? Tell me, who are those remaining 3 elements? Who are those remaining 3 elements? Those are 2, 5, 6. Okay, those are 2, 5, 6. Those remaining 3 elements are 2, 5, 6. So the answer will be, you select exactly 2. Selecting exactly 2, how many ways? Selecting exactly 2, how many ways? From 3 you are selecting 2. And any superset you create from the remaining 3 elements, that will be, so finally I can say, for this vertex 1, 3, 4, for this vertex, what is the degree? The degree will be, you select 2 of them, multiplied by the remaining elements. They have 2 choices. Okay, the remaining elements have 2 choices. That's it. This is your degree. So finally I can say here the degree will be 3 into 2 to the power 3. If you have 4 size, if you have subset size is 4, then what will happen? If your subset size is 4, then what will be the degree? Subset size is 4. Like consider this vertex, like 1, 2, 3, 4. Consider this. So again, what will be degree? Very simple. From these you take 2 people. From these you take 2 people multiplied by remaining 2 people have 2 choices. Remaining 2 people have 2 choices. Yes or no? Remaining 2 people have 2 choices. Also, if you say subset size 5, like consider this subset 1, 2, 3, 4, 5. You take 2 people from here. From these 5 you take 2 people. You take 2 people. And the remaining person has 1 choice. The remaining element, either you can take it or you can leave it. Take it or leave it, take it or leave it. Okay. Next, 6 size. Like finally this vertex. Just take 2 elements from here. That's it. That's it. Now, which is the largest value? Which value is the largest value? So you can calculate. You can calculate all the values that are there. You can calculate like 6C2. What is that? That is 6 into 5 divided by 2. So that is 15. Okay. So what is this value? This is like 10, so that is 20. What is this value? 4C2, that is 6 into 4, that is 24. This is 24, this is 16. So what is the maximum degree? The maximum degree people are these are the maximum degree people. So the maximum degree, that is 24. So when you put n equal to 6, answer should be 24. So what we have done? We have done this. Then this we have seen that when n equal to 6, then answer is what? Answer is 24. Answer should be 24. This is the maximum degree that will be there. So which option is giving you 24 when you put n equal to 6? So this is gone. This option gone. Okay. This option gone. What about this option? And look at this option. What this option is? This option is 3C2. 3C2 multiplied by 2 power 3. 3C2 is 3 multiplied by 2 power 3. Oh, that is 24. That is 24. Okay. And what this is? This is 3 multiplied by 2 power 3. This is also 24. Oh, okay. So here you are stuck. Okay, you got stuck here. But okay, so 2 options are gone, but still 2 options are remaining. Still 2 options are remaining. But at this point of time, in those 3 hours, what will happen? Tell me. Tell me, at this point of time, like assume you are in the GATE exam. Okay, just imagine that you are in the GATE exam and you are solving like this. You are taking n equal to 6, you are solving like this. But 2 options are still remaining. But one beautiful thing will happen in the GATE exam after this analysis. The analysis that we have done so far, imagine you are in the GATE exam, what will happen? Can you tell me? Like at this point of time, see, at this point of time, I did not tell you the complete analysis. I do not give you complete analysis, but at this point of time, can you generalize the result? Tell me, can you generalize the result? Don't take 7. Now don't take n equal to 7. Forget about n equal to 7. Can you generalize? Forget about n equal to 7. Of course, you can take n equal to 7. That will definitely work. But can you generalize now? Now you have the knowledge. Now you know how to do this. This question. What is the idea of this question? You have completely understood this question. Do you agree with me? At this point of time, you have completely understood the question. What is happening in the question? How to approach this question? Okay. So now in the GATE exam, if you are in those 3 hours, then now you can generalize this immediately. Or you can take n equal to 7, of course. That is your choice. But you can generalize this. So let's generalize this now. Now I will tell you the complete analysis. So far, I did not give you the complete analysis. I was just making sure that you understand the question. But now let's see the complete analysis. Are you ready for the complete analysis? This is a beautiful, something beautiful is coming. Something beautiful is coming now. Okay, just understand. So you have this set. In this set, you have total how many elements? Total n elements. Okay, you are creating a graph. In this graph, you have set of vertices is power set of S. So you have total 2 power n vertices. There are 2 power n vertices. Okay, and there are edges. There are some edges. Okay. Now, what we are going to do in this question? Again, the same chart we will create. We will create what is the subset size? Subset size of vertex. And here we will write the degree of vertex. Degree of that vertex. So this chart we will create. So again, what I'm going to do? So you tell me, if your vertex subset size is 0, means, okay, if your subset size is 0, then degree is also 0. If your subset size is 1, degree is also 0. If your subset size is 2, consider this vertex. Look at this vertex. What will be the degree? Any superset will work. Do you agree? Any superset will work. Yes or no? Correct? Any superset will work. Any superset. How many remaining elements? How many remaining elements? Total n minus 2 remaining elements. Any superset. by remaining elements, by remaining n minus 1 elements, by remaining n minus 2 elements. So any superset, so that means every remaining element has two choices. Yes or no? Every remaining element has two choices. Every remaining element has two choices. Either you take it or leave it, take it or leave it, take it or leave it. Yes or no? All the remaining elements that you have, so they have two choices. So n minus 2, because there are these many remaining elements, so the degree will be 2 power n minus 2. Very good. Okay, let's move on. Size 3. Size 3, what will be that? So for example, you can take 1 2 3, you can easily do. What you will do, you will take two people from here, correct? You will take two from here, you will take two people from here. So from these three people you will take two people. Remaining people have again two choices. Yes or no? Again, what I can say, I can say again remaining. How many remaining? These three, not these three. Remaining n minus 3 elements have two choices each. Have two choices each. Do you agree? Please tell me. See, forget about array. See, some students are thinking, sir, in the GATE exam how we will do? GATE exam के अंदर कैसे करेंगे? सर ये आइडिया GATE exam में कैसे आएगा? अरे forget about GATE exam. Right now you are not in the GATE exam. You are in the preparation phase. When you are in the preparation phase, just do the complete analysis. If you do complete analysis of 1000 questions, then very high probability that in the GATE exam you will be able to solve the new question. In the GATE exam, this question will not come. This question that we are solving right now, this question will not come again in the GATE exam. It will never come in the GATE exam again. In the GATE exam, something new will come. Like in the Go Classes test series, did you give Go Classes mock test 1? All India mock test 1. Go Classes All India mock test 1. Did you attempt that? In that you have some new questions, right? Yes or no? Those questions you have never seen. Okay, so remember one thing, when you do the complete analysis of 1000 questions, then automatically what will happen? Probability will increase that the new question that will come in the GATE exam, you will be able to solve it. So, okay, now those students who are thinking, GATE exam में कैसे करेंगे, GATE exam में कैसे करेंगे, forget about GATE exam. You are in the preparation phase. Focus on learning. Are you understanding what I am telling you right now? Are you understanding this analysis, this complete analysis? Are you understanding? Okay, if you are understanding that, you are enjoying also, right? When you understand something new, you will enjoy, you will get a feeling of enjoyment. Like you will feel very happy, you will feel that you are understanding something new, some beautiful analysis you are understanding. Okay, then you will feel happiness. Are you feeling that happiness? Simple point. During the preparation, that happiness is all we want. Okay, just keep improving and don't worry about the GATE exam. It's like, you know, that 3 idiot dialogue. Run after excellence. If you run after excellence, automatically GATE top rank will come. Okay, automatically in the GATE exam, you will be able to do it. Okay, anyway, so now tell me. So you let me know. So you can notice the remaining elements, the remaining n minus 3 elements, they have two choices each. Each of them have two choices. The remaining n minus 3 elements, they have two choices each. Okay, what about the next one? Like if you have subset size 4, then what will happen? If you have subset size 4, then what will happen? What is the degree? From them you take two people. You take two people from them. So from these 4 people, you take two people. Now, the remaining people, remember, if you take two people, exactly two people you can take. Exactly two people you can take. You cannot take the third person. For example, if you take 1, 2, you cannot take this 3. You cannot take this 3 because we want exactly two common elements. Okay? Two people are adjacent if they have exactly two common elements. So remember, you can only take two people. So you are taking two people. Okay, after that, again the same thing will happen. Remaining, again the same thing. Remaining n minus 4 elements have two choices each. Okay, so the answer here, the remaining n minus 4 elements, they have two choices each. The same thing, if you have size 5, If you take size 5, the same thing will repeat. If you take size 5, okay, the same thing is going to repeat. The remaining n minus 5 people. So from these 5 you select 2, the remaining n minus 5 people, they have 2 choices each, and so on. So now can you generalize? If you have k size subset, if you have k size subset 1 2 3 tuck, 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 tuck. Okay, so if you have k size subset where k is, of course this k must be less than equal to n and greater than equal to 2. Okay, tuck, tuck. Okay, so tell me now, in this what will be the, so again what you will do, from these k you will take 2 people, from these k you will take 2 people, you will take 2 people from these k people multiplied by remaining n minus k people have 2 choices each. Okay, remaining they have 2 choices each. This is the degree. This is your generalization. Once your generalization is over, now we have to find who is maximum. Work is not done. Yes or no? Okay, yes or no? Work is not over. Now we have to find maximum. Correct? So let's find out maximum. What is the maximum here? Okay, so let's find out. Now actually, if you notice what is happening, so let me tell you. Did you notice there are 2 things happening in the multiplication? 2 things are happening. Did you notice a small observation? Did you make? Here you have subset size and here you have degree. Did you make this small observation? Subset size 0, degree 0. Subset size 1, degree 0. Okay, forget about these cases. Now, beautiful things. When you have subset size 2, then there are 2 things happening. 1 multiplied by 2 power n minus 2. So there are 2 factors. Factor this, factor this. There are 2 things multiplying. When you have subset size 3, then what you have? Then you have 3c2. What is 3c2? Can you tell me? What is 3c2? Array, what is 3c2? That is 3 multiplied by 2 power n minus 3. So there are 2 things happening here. Let's call it quantity B. Let's call it quantity B. Let's call it quantity A. Let's call it quantity A. So this is your quantity B and this is your quantity A. Okay. If you have 4, then what will happen? Then 4c2, that is 6. And this is n minus 4. If you have 5, then what will happen? Then you have 5c2, that is 10. Quantity n minus 5. Now see what is going to happen. 6. If you have 6, then what will happen? If you have 6, then what will happen? 15 into n minus 6. Can you say that quantity B is dividing by 2? Can you say when you go like this, quantity B, can I say quantity B being half? Yes or no? Can you say quantity B is being half? Can I say this? And what about quantity A? Like, is this doubling? Can I say, is this doubling? This is not doubling actually. This is not doubling. Here it is doubling, but then it is not doubling, not doubling. Okay, it is not doubling, right? This quantity is doubling here. Actually, here tripling, then doubling, then less than doubling, then less than that doubling, then less than that doubling, less than that doubling. Okay, is this clear? Is this clear what happened? Here tripling, here multiplied by 3, here doubling, here less than doubling, here even less than doubling, even less than doubling. Okay, so what I am saying, I am just saying a simple thing. I am saying that there are 2 things. One is A, one is multiplied by B. If this quantity becomes half, but this quantity, let me assume this does not double, like less than double. If this becomes 1.5A, then ultimately, which is bigger, X or Y? Which is bigger, X or Y? Which is bigger, X or Y? Tell me. Which is bigger, X or Y? So definitely X is bigger. Right? Yes or no? X is bigger because you are dividing by 2, but you are not multiplying with enough. Yes or no? X will be bigger if this happens. So the same thing is happening here also. What is happening? See, initially you have this, here you have subset size. Okay, that's it. Your answer is coming now. Your final answer is coming now. Subset size, let's focus on 2 3 4. Let's focus on 2 3 4 5 6 and so on. So these are the subset size. Now your answer is coming. Your degree, here you have here you have 2 power n minus 2. This is your quantity B, remember. This is your quantity B. Okay, and this is your quantity A. Now what happened? Now this quantity tripled. Yes or no? This quantity tripled, but this quantity divided by 2. Yes or no? This quantity tripled. So who is bigger? Like what I'm saying A multiplied by B. Let's assume this triples, but this divides by 2. Who is bigger? X or Y? Who is bigger, X or Y? This is tripling. This is dividing by 2. Who is bigger, X or Y? So definitely Y is bigger, because you are multiplying by 3 but dividing by 2. Ultimately Y will be bigger. Okay, so this is the same thing happening here. So I can say that this is, can I say this is greater than, like I can say something like this. Like this value will be definitely here, the you are increasing. Increase happening. Okay, what about this 4? This 4 means it is like 6a. It is a 6a doubling, and this is a b by 2 divided by 2, like b by 2 divided by 2. So it is equal, right? No, okay, it is equal. No changes, yes or no? It is like this scenario. It is doubling, this is also like dividing by 2. So here both will be same, correct? Here both will be same. Is this clear? So like you are doubling, here you are doubling, but you are dividing by 2. Okay, so it's like doubling, and but you are dividing also by 2. So they will be actually same. Okay, what about this? Now here you are doing 10a, but again you are dividing by 2. Again you are dividing by 2. It's like this. You are dividing by 2, but you did not multiply with, you multiplied with less than 2. So can I say this is decrease? Now this decrease will keep happening. Again the decrease will happen, because you will divide by 2, but you will not increase by, you will not multiply with 2. So so this decrease will keep happening now. So tell me, where did you get maximum? Where did you get maximum? You are decreasing. So you got maximum here. This increase happened and this equaled, here you got the maximum. Here you got the maximum. Okay, mind blowing. How many of you will say, like, just comment, okay, if you think this question, this analysis, the solution, if you think this is like mind blown, just comment mind blown. Like, you tell me, like, did you like this solution? In the GATE exam, you can solve it. See what I'm saying. In the GATE exam, in those 3 hours, what you can do? You can take n equal to 6. Then 2 options will be remaining. 2 options will be gone, 2 options will be remaining. But at that point of time, okay, when 2 options will be remaining, at that point of time, you will understand what is happening. You will understand the behavior of this question. Then you can generalize, or you can take n equal to 7. See, there is no problem. You take n equal to 7, you can solve it. If you take n equal to 7, you will be able to solve it. Okay. Is this clear to everyone? Please tell me. Did you understand? Okay, forget about GATE exam. Okay, like forget whether you will be able to do this in the GATE exam or not. Because in the GATE exam, you don't have to solve all the questions. Please understand. GATE exam is not about solving each and every question. Okay, GATE preparation means just do the complete analysis of everything. So now simple question I am asking, did you understand? Okay, this analysis, did you understand? Whether you are able to do this yourself or not, that is a different thing. Don't worry about it. See, in this world, let me tell you, in this entire world, there is not a single person who can solve all the problems by himself or herself. So some students, what they think that I'm sir, you solved it, I understood it, but I was not able to solve it myself. It does not matter. Does not matter. Not every question you can solve by yourself. Do you agree? Yes or no? But once, just understand the complete analysis. Once you understand the complete analysis, then some improvement will happen in your mind, okay, in your knowledge. Some improvement will happen. Basically, now you are upper than you were before this question. Before solving this question, before seeing the complete analysis of this question, let's assume you were here, now you are here. So you have improved. Be happy about it. Be happy about the improvement. So okay, so finally, did you understand this? Please tell me. Let me know. Okay, so now anyway, so that's it. This is your complete analysis of this question. I hope you understood. So finally your answer is what? Let's see the final answer. So the final answer is coming for 3,4. So your final answer, maximum degree, that is coming for 3,4. So this maximum degree is coming when? This maximum degree is coming when? This is coming when you take vertex whose subset size is 3. When you take subset size 3 or 4. When you take subset size 3 or 4 vertex. Okay. So when you take subset size 3 or 4 vertex, then what will be the degree? Okay. For this vertex, what will be the degree? The degree will be very simple. That will be from these 3 elements, you select 2 elements, and the remaining n minus 3 elements. Or this is same as 4C2 multiplied by 2 power n minus 4. These are basically same. Okay. So your answer will be this. So finally your answer is what? Finally your answer is this. This is also correct. Like if you do this, 4C2 multiplied by 2 power n minus 4, this is also correct. Both are correct. Okay. So this is your answer. Okay. Answer is option C. Okay. So is this complete analysis? Variation is remaining, right? Yes or no? If you see, I don't know whether you are first timer. If you are first timer in the Go classes, let me tell you a property of Go classes. This is the property that we do the complete analysis of the questions. Whatever question we solve, we always do the complete analysis. Getting the answer is not enough for us. Okay, our students, Go classes students, they don't stop after getting the answer. If they get the answer, they will not stop. They will do the complete analysis in every subject. Whatever subject you take, we always do complete analysis of that question. For every GATE question, we always do the complete analysis. Okay, so getting the answer is good, but that is not enough. Okay, you should do the complete analysis. Now variation is remaining, some variation. So let me ask you one variation. How many components in the previous question? Let me ask you a variation. Can you solve it? Can you try this? How many components? How many connected components? How many connected components? How many connected components in G? In the previous question, of course. The answer will be, basically there is 1 for 5. This is for 5. Okay. And this is for one side subset. These are isolated, right? Okay. So these are the components. Plus there will be one more. So the answer will be n plus 2. I agree. This is correct answer. But how to prove that the remaining will be in single component? How to prove that there is a, see what you have to do. There is a path between every 2 remaining vertices. Okay, this is what you have to prove, correct? Prove that between any 2 subsets of size greater than 2, between every 2 subsets of size greater than or equal to 2, there is a path. There is a path. Did you prove it? Anyone? Please tell me, did you prove it? Like, or did you randomly say n plus, did you randomly say n plus 2, or did you prove it? See, you are saying that the remaining will be one component. You are saying for remaining there will be one component. This is what you are saying, correct? You are saying that for the remaining, for all remaining element vertices, there will be one component. For remaining one component. This is what you are saying. But how can we prove it? Like, how can, first of all, this statement is true or false? Like, if I say there is a age, is this true or false? Is this true or false? Tell me. This is true or false? This is true or false? Tell me. Simple question I am asking. Is this true or false? Between every two subsets of size, there is age. So this is definitely false. For example, there is no age between them. Like take 1, 2, 3, 1, 2 and take 3, 4. There is no age. So you can notice there is no age. No age between them. Okay, so between them there is no age. So definitely this statement is false. But what about this statement then? Now, so prove that, this is what we have to prove, that between every two subsets of size greater than equal to 2, there is a path. There is a path. So how to prove it? See, very easily you can prove. First of all, you can prove that if you have two subsets of size 2, then what will happen? Like if you have, let's assume you have two subsets. So first I will prove, actually what I will prove, first I will prove that between any two subsets of size 2, any two subsets of size 2, there is a path. There is a path. How to prove it? Can you tell me? This is a simple question. Can you tell me how to prove it? Tell me. Between any two subsets of size 2, there is a path. How to prove it? Anyone? There are two cases possible. There are two cases possible. Either the case is possible like this. For example, they have nothing common, like 1, 2 and 3, 4. They have nothing common. Then there is a path. You can create a path. What you can do? You can easily create a path. This will be adjacent to 1, 2, 3. Sorry, this will be adjacent to 1, 2, 3, 4. This will be adjacent to this. This n is greater than equal to 6. This is already given in the question. This is already given. So what you can do? You can create a path. Okay. So you can easily see there is a path. Right? Yes or no? So this case 1 is over. Case 1 is over. Okay. What about case 2? Case 2, when they have one element common, like 1, 2 and 2, 3. When they have one element common, then also it is very simple. They are adjacent to whom? They are adjacent to 1, 2, 3. They are adjacent to 1, 2, 3. Again, this case 2 is done. So this case 2 is done. This case 1 is done. So that's it. So we have proven it. Yes or no? So this proof done. Correct? Proven. Do you agree or not? We have proven it. This we have proven that between any two subsets of size 2, there is a path. Yes, and proven. Okay? Yes, and proven. Now you can see that. Now you can see that every subset of size greater than 2 will have age with. Now the only thing you have to prove is, now what you have to prove? Okay? For any, now this is what you can prove. For any subset of size greater than 2, there is a adjacent subset of size 2. This also very easily you can prove. For example, if you take 1, 2, 3 and so on k, where k is greater than 2, then it will be adjacent to 1, 2. That's it. That's it. This is your proof. So finally what we have done? So we have proven. So what we have proven? We have proven that if you take any subset you take, whatever subset you take, okay, any greater than or equal to 2 size subset, it will, okay, so what it will have path, or I can say any greater than 2 size subset you take, that will be adjacent to some 2 size subset, okay, adjacent, and that will have path, and that will have a path to any 2 size subset. So did you notice that? So here there is a edge and here there is a path. So that's it. This is another proof, another variation. This is very simple, but did you understand? Like this proof also, did you find it did you find it nice that, okay, what is happening here? We are proving that between any two vertices whose subset size is greater than or equal to 2, there is a path. We are proving, okay, we have proven. This is what we have proven, that if you take any subset, any 2 subset you take whose size is greater than or equal to 2, okay, who has size greater than or equal to 2, any 2 subset you take, they will have a path between them. We can create a path between them. This is your third question. Now the complete analysis is over. Okay, so now you are free from this question. Okay, see, this type of simple proof, these are also very interesting. They will also improve your knowledge. Like, please tell me, this proof, this simple variation, okay, did you understand? Did you feel it good? Like, did you feel, I can say, yeah, okay, that it is a good proof. It is a simple, cute proof, I can say. Okay, so this type of proof, you can say this type of proofs are basically cute proof. In ISC, in Indian Institute of Science, okay, so I did my MTech from IISc Bangalore. So there is a professor who says whenever he tells this type of proof, this type of simple proof, whenever he tells, he will say this is a cute proof. Okay, so this is the word he uses. So the same word I am using. You can basically, the professor name is you can go to ISC and you can check it out. Okay, so the professor name is Sunil Chandran, Professor Sunil Chandran. So whenever he will tell you a simple proof, okay, this type of simple, I can say simple cute proof, he will tell you, then they will say that this is a cute proof. Okay, so Professor Sunil Chandran, okay, brilliant professor, like excellent professor. He was my guide, Professor Sunil Chandran. So they were my guide in my MTech. Okay, let me just tell you, I have done my specialization in graph theory. Okay, so this graph theory was my specialization. I have done project in this graph theory. So anyway, let's move on. So this question is over. The complete analysis of this question is over. Now you are free from this question. Okay, so a lot of time we have spent on this question, but anyway, clear? This question is clear? This GATE 2006 question, the complete analysis is over. Now you are free from it.